This video has been sponsored by Audible. In general, I've always liked weird chemical transformations, and over the years, I think I've done a few good ones. Like turning my pee into an artificial sweetener and tasting it, and turning toilet paper into drinkable alcohol. Something that I've always wanted to do, though, was turn plastic gloves into grape soda. At first, this might seem a bit ridiculous, but like all of my other transformations, it's possible because the chemical world is often weirdly connected. In this case, there happens to be a chemical in plastic gloves, specifically vinyl ones, that's distantly related to fake grape flavor. It's not found in every vinyl glove, but a lot of them contain something called the phthalate ester. It's included to make the vinyl more durable, soft, and malleable, and this is chemically what it looks like. This, on the other hand, is one of the most commonly used fake grape flavors called methylantranolate. Considering that one just smells like plastic and the other is supposed to smell and taste like fruit, they're shockingly similar. There are at least a few main differences, but the core of them is almost the same. They share this ring and this small portion here, and in theory, it should be possible to convert one into the other. So basically, my goal was to pull the phthalate ester out of some vinyl gloves, turn it into grape flavor using some chemistry magic, and then use that to make some grape soda. It unfortunately wouldn't be super easy though, and it would take at least 5 major steps. Also, just like all my other transformations, I had no idea if it would actually work. But anyway, to get things started, I first had to find some vinyl gloves that had the phthalate ester in them. Over the years, though, they've become a lot rarer because phthalates have been associated with some negative health effects. A lot of companies have replaced them with safer or greener alternatives, and these wouldn't work at all. I was only able to find one company called Adena that for sure had the phthalate in it. So I ordered a box of it, and it arrived a couple weeks later. I then cracked it open, and I pulled out 20 gloves. The next thing to do was to cut them up into a bunch of small pieces, which kind of ended up being a huge pain. It turned out that cutting 20 gloves at the same time with a pair of scissors was a lot more annoying than I thought. When I was eventually done, though, I put the beaker onto a hot plate and I added isopropyl alcohol until it was completely covered. I then pushed down some of the pieces and I put a bowl filled with ice on top of it. After that, I turned on the hot plate and I brought it all to a boil. What I was doing here was using the alcohol to dissolve the phthalate ester and to pull it out of the glove. The phthalate ester actually represents a huge portion of the glove, and it's apparently around 41% of it. The rest of it is mostly just vinyl plastic, which is insoluble, and that just gets left behind. I let it boil like this for an hour, and then I poured it all through a funnel plugged with some cotton. This was done to get rid of all the glove pieces, which I didn't need anymore. At this point, everything that I wanted should have been in the alcohol. After this, I put it back on the hot plate, dropped in a stir bar, and brought it back to a boil. The goal now was to concentrate it by getting rid of about half of the alcohol. So this time, I didn't include the bowl on top to condense the vapors, and I left the beaker completely open. When it was done, I pulled it off the plate, and I let it cool down. When I came back to it, something had separated out, and there was a film at the bottom. I'm not entirely sure what it was, but it was either a bit of vinyl plastic or some of the other additives that were in the glove. To clean it up, I filtered it again, and I drained everything directly into a large flask. After this, I got out a beaker and I added 25 grams of sodium hydroxide drain cleaner to 300 mils of water, and I stirred it until it all dissolved. I then poured all of this into the flask with my alcohol, and it kind of separated into two layers. The top yellowish one was the alcohol mixed with the phthalate ester, and the bottom one was the solution that I just added. I then set it up for a reflux by adding a heating mantle and a condenser column. When it all looked good to go, I started the stirring and I cranked up the heating. As it warmed up, it got less and less cloudy, and by the time it was boiling, it had completely cleared up. Now, what I had to do was keep it boiling for 2 hours. What I was doing here was splitting apart the phthalate ester, which was called diisononyl phthalate, or DINP for short. The sodium hydroxide was attacking it and breaking it into sodium phthalate and isononyl alcohol. The sodium phthalate was the part that I specifically needed for this project, and the isononyl alcohol was technically just a side product. When it was done, I turned off the stirring and I took away the heating mantle. I let it cool down a bit for around 20 minutes, and then I poured it all into a separatory funnel. I waited a few minutes for the layers to separate, and then I drained the bottom layer into a beaker. This bottom layer was mostly water, and it contained the sodium phthalate. The upper one was a mixture of the isopropyl alcohol and the isononyl alcohol, and I poured it all into a separate container. I mentioned before that the isononyl alcohol was just a side product in this project, but just by chance, it happened to be something that I needed. I have no idea when I'll actually get around to using it, but in a future video, I will probably use it to make some synthetic hot sauce. Now, to this cloudy solution, I added 50 milliliters of concentrated hydrochloric acid. The first thing that this was doing was just reacting with leftover sodium hydroxide drain cleaner, and it generated a lot of heat. It was also reacting with the sodium phthalate, though, and turning it into phthalic acid. After a few minutes, I tested the pH, and it was around a 4, which was barely acidic. It had to be much more acidic and closer to something like 1, so I added some more hydrochloric acid. This time when I stirred it, it started getting really cloudy, and this was all phthalic acid that was separating out. I again tested the pH, and it was now about 1, which was perfect. The mixture that I had here was still quite hot, and to get out as much phthalic acid as possible, I had to cool it down. To do this, I just put it in the fridge, and I left it overnight. The next day, it looked like there was a bit more, and I used a vacuum filter to get rid of all the water. I also washed it a few times with some fresh water, and I eventually had some relatively clean phthalic acid. Now, the next thing that I had to do was convert all of this into something called phthalic anhydride. To do that, I just dumped it all into a big beaker, and I turned on the hot plate. As it warmed up, it started giving off water vapor because the crystals were still a bit wet. I then stirred it until it looked like all the steam was gone, and I quickly put a flask on top of it. At first, it looked like it was just fogging up again. However, it was also forming some fluffy white crystals. This was all phthalic anhydride, and this was basically the entire reaction. The high temperature was splitting apart the phthalic acid and turning it into the phthalic anhydride and water. Normally, phthalic anhydride is a solid, but because of the high temperature, it was getting vaporized as it was formed. This vapor then rose to the top and started depositing itself on the flask and the colder part of the beaker. What I had to do now was wait until a decent amount had formed and then harvest it. However, I had to let it cool down first, because if I took the flask off while it was still hot, it would shoot out a bunch of the phthalic anhydride. After sitting there for a couple minutes, though, it usually wasn't angry anymore, and I could open it up and scoop out all the crystals. It initially looked like there was quite a bit, but it was all just super fluffy. I moved it around until it kind of looked like a cotton ball, and then I was able to lift it out. I then put it back on the heat, and I again waited for more crystals to form. Now, what I had to do was keep repeating this cycle until all of the phthalic acid had been converted. At first, I was having a lot of fun harvesting these puffballs, and I naively thought that it wouldn't take very long. However, I slowly realized how wrong I was when I was still doing the same thing over an hour and a half later. It turned out that because it was so fluffy, it just looked like I was making a lot. In reality, each run barely gave me anything, and it started feeling like it was a never ending process. Eventually, though, about 3.5 hours later, it stopped making any crystals, and the pain was finally over. In total, I ended up getting 11.5 grams of really pure and fluffy phthalic anhydride. So far, everything was going really well, but I was starting to get a bit worried. 11.5 grams was a decent amount of phthalic anhydride, but the rest of the process was really inefficient. I would lose a lot of product with every step, and I might not have much of anything by the time that I got to the grape flavor. So last minute, I decided to process the other 80 gloves that were still in the box. Ideally, I would have done this in one shot on a much larger scale, but unfortunately, I didn't have the equipment for it. So, I just did 4 runs of the same thing, all at the same time. The first extraction part wasn't too bad, and it felt like I was running a little factory. The phthalic anhydride part, though, was really painful, and it took another 3.5 hours. It was actually even worse than before, because this time I had to keep cycling between 4 of them, and I wasn't even able to take a break. When it was eventually done, I had a bunch more phthalic anhydride. What I did find odd, though, was that the batches weren't very consistent. I had two that were closer to 11, one that was around 12, and one that was above 13. I have no idea why this happened, but either way, I now had 58.4 grams in total. This was way better than just 11 and a half, and this made me feel a lot more confident. Now, the next thing to do was turn all of this phthalic anhydride into something called phthalimide. To make this happen, the first step was to compress the puffballs because right now, they were mostly air. I did this by just stabbing them and mixing them around, and I did it for every bottle. When I was done, it was still mostly air, but it was significantly better than it was before. I then shoved everything that I had into a large flask, and it almost filled the entire thing. Now, with all the phthalic anhydride loaded, I dumped in the only other ingredient that I needed, which was 12 grams of urea. In the past, I purified urea from my own pee, and I do still have some of it, but it unfortunately wasn't enough for this. So instead, I got this urea from an instant cold pack. But anyway, with everything in the flask, I shook it around to mix it as best as I could. When I felt that I had done a decent job, I put it back on the stand, and the next thing to do was heat it up. Normally, I would have used a heating mantle like I did before, but I had to accurately monitor the temperature. The easiest way to do this was by using a hot oil bath, and I set one up using vegetable oil. When it all looked good to go, I turned on the hot plate and I waited for it to warm up. As it got hotter, the volume of the stuff in the flask slowly decreased, and there was some vapor coming off. Besides that, though, it didn't look like much was happening, and this was because there probably wasn't. Right now, the urea and the phthalic anhydride were still in the solid phase, and they had a hard time reacting. When it got to around 130 C, though, they started melting and mixing together. As a liquid, they were reacting much more efficiently, and they were combining to make phthalimide and CO2 gas. When I had done this reaction before, it had completely liquefied, but that didn't really happen this time. I mean, it kind of melted, and I did see some bubbling liquid. However, this didn't last for very long, and I think it was because the phthalic anhydride was way too puffy. This started getting me really worried that this reaction was a complete failure. So, what I decided to do was just try and force the reaction by slowly heating it up to 170 C. I was hoping that it would melt again or something, but it didn't look like too much happened. As a last attempt to fix it, I decided to try mixing it around. I thought that maybe the puffiness of the anhydride had prevented it from properly mixing with the urea. Even though it hadn't really melted, it had compressed a lot, and it was quite hard. This made me think that it would be really hard to break apart, but it was surprisingly easy. I then heated it for another 30 minutes at 170 C, and again, it looked like nothing happened. It was producing some ammonia gas, though, so it seemed to be doing something. After this, I had no idea if it had actually worked, but I had faith that it did. I figured I would just move on to the next purification step, and I would find out pretty quickly if it had failed. I dumped everything that I had into a beaker, and on top of it, I added 500 mils of hot water. What I had to do next was bring this all to a boil and to keep it boiling for at least several minutes. For some reason, though, the hot plate that I was using just didn't get hot enough, and I had to swap it out for a different one. I then cranked up the heat, and it only took a couple minutes to start boiling. The goal here was to get rid of any unreacted urea or phthalic anhydride. In the boiling water, any urea would easily dissolve, and the phthalic anhydride would get turned back into phthalic acid and then dissolve. The chemical that I was hoping I made, though, phthalimide, was nearly insoluble and it would just stay as a solid. So, what I was waiting for here was to see how much of this stuff would disappear. I was honestly really scared that it would all just dissolve, but it didn't. Even after boiling it for a while, there was a lot of solid stuff, and this was a really good sign. I didn't know how much phthalimide there was, but I had definitely made some. While it was still hot, I poured it all into a vacuum filter and I pulled off the water. I washed the powder a few times with boiling water, and then I dumped it all into a bowl. At this point, it was still kind of wet, so I threw it into an oven for a few hours. When it was done, I had 46.7 grams of nice and dry phthalimide, which was way more than I had expected. I mean, it still wasn't as good as it could have been, but it was more than good enough. Now, the next step was to make anthranilic acid, and this was the part that I really wasn't sure about. Making it from phthalimide is notoriously annoying, and it has a tendency to completely fail. Everything had to be done very carefully, and even slight mistakes could turn it into a huge mess. However, I'd done it years ago, and I'd found what I thought was a decent way to do it. I figured if I just repeated exactly what I did, it should turn out fine. The first thing that I needed was to get some concentrated bleach, which usually has a concentration between 8 and 10 when it's fresh. Bleach slowly degrades over time, though, and I had to know its exact concentration. To do this, I put together this little setup. In the main flask, I loaded it with a very specific amount of bleach, and in the addition funnel above it, I added some 3% peroxide. When I opened the stopper and I let them mix together, they reacted to make oxygen gas. I added enough peroxide to destroy all the bleach, and all of this oxygen was bubbled into an inverted grad cylinder. This let me measure how much oxygen was being made, and from this, I was able to do some calculations and find out the concentration of the bleach. I did it 5 times to get a good little set of data, and it averaged out at around 11%. Now that I knew this, I could get started, and I added water to a flask along with some sodium hydroxide drain cleaner. I let it stir until it all dissolved, and then I put together an ice bath. I also added a thermometer, and I waited for it to cool to around 0 C. When it eventually got there, I started adding the bleach, and the amount that I used was based on that 11% concentration that I had just calculated. As I did this, the temperature would increase a bit, and it was important to keep it below 5°C. To help with this, I pre cooled the bleach in the fridge, and I also only added it in small portions. When I was done, I took the flask out of the ice bath and I dropped in a funnel. Now, what I had to do was add all the phthalimide, and I started dumping it in. As it mixed with the bleach, it didn't look like much was happening, and this was mostly because it wasn't very soluble. After everything was added, I washed the funnel with some water. At around the same time, though, the mixture in the flask got a lot thicker, and the magnetic stirring stopped working. To fix this, I basically just had to wait because the phthalimide was slowly reacting with the sodium hydroxide drain cleaner. This was turning it into sodium phthalimide, which was actually soluble in water. Over the next few minutes, the stirring started working again, and the phthalimide slowly disappeared. Up until now, everything seemed to be going pretty well, but then it started turning yellow, and it quickly became orange. The temperature also started to rise, and it eventually peaked around 45°C. This was unfortunately exactly what I wanted to avoid. When I did this reaction before on a small scale, it was totally fine, but apparently on a larger scale, there are some temperature issues. What was supposed to be happening was a reaction called the Hoffman rearrangement, where the bleach was reacting with the phthalimide to make sodium anthranilate. The major problem, though, is that if the temperature gets above around 20°C, it starts making colored side products. Ideally, it would have been colorless, but at this point, it still didn't look too bad. I had faith that it could still be okay, and I figured it was worth continuing. I mean, I had also used everything that I had, so I didn't really have a choice. After this, I added some more cold sodium hydroxide solution. I was kind of expecting it to make the color even darker, but it pretty much stayed the same. Now, at this point, the temperature sensitive part of the reaction was done, and the next thing that I had to do was heat it up. So, I put it in a hot water bath that I'd set up at 80°C, and I left it there for 30 minutes. This just really helped drive the reaction to completion and to push it all into being sodium anthranilate. When it was done, it looked almost exactly the same, and I poured everything into a beaker. I then washed the flask with a bit of water, and I set up another ice bath. When it had cooled down to around 0°C, I tested the pH, and it was strongly basic. This was from all the drain cleaner that I had added, and what I had to do next was make it acidic. To do this, I started adding dilute hydrochloric acid. This would generate a lot of heat though, so I did it slowly to keep the temperature around 0°C. I also had to keep checking the pH using some pH papers. Every time it was added, it released some bubbles, and this was all CO2 gas. Eventually, though, some solid stuff started appearing, and I think this was the anthranilic acid that I wanted. However, the solution was still too basic, and it just quickly redissolved. When it got to around a neutral pH of 7, it was starting to get cloudy, which was good, but there was also some junk floating around. I decided to quickly get rid of this by just filtering it through some cotton. I'm really not sure why, but as it was filtered, it somehow got darker. When it was done, I put it back on ice, and I continued adding the acid. It made more CO2, and the anthranilic acid that appeared stayed longer and longer. It again got darker though, which I didn't really like. Eventually, the anthranilic acid started to actually stay, but by this point, it was almost black. I checked the pH and it was around 5, which was slightly acidic, but I wanted it to be 4. This is because it's at that pH that the anthranilic acid is the least soluble. Above or below 4, it tends to act as a base or an acid, and it becomes more water soluble. At 4, though, it's a neutral molecule and it becomes almost insoluble in water. Ideally, the anthranilic acid would have been white or maybe slightly yellow, but what I had here kind of looked like a bunch of dirt. This again was because it got too hot and caused a bunch of side reactions to happen. If I had the chance to try it again, I'd mix the chemicals in a different way to avoid the temperature issue. But I really only had one shot at this, and I was gonna have to deal with the mess that I made. When it eventually got to that pH of 4, I poured it all into my vacuum filter. I then washed it a few times with water, and I was really hoping that it would magically take away some of the color. However, it didn't seem to make any difference. What I had now was a bunch of crude anthranilic acid, and it was way more than I ever thought I'd get. I was really tempted to just move on to the next and last step with this, but it was a little too dirty. I was going to have to at least try and clean it up a bit, and I decided to do a recrystallization. So I dumped it all into a beaker, along with a bunch of boiling water. I also added some activated charcoal to see if it would get rid of the color. I boiled it for a few minutes, and then I filtered it all into a flask that was kept hot by a hot plate. When everything had passed through, I took it off, and I waited for it to cool to room temperature. It took a while, but some really nice, white crystals started forming, which I was really happy about. The liquid was so dark that it was hard to see, but there were also crystals growing inside. I let it fully cool overnight, and the next day, there were a lot more crystals. They unfortunately still kind of looked brown, but I was hoping that it was just the really dark solution that was making it look like that. I then filtered them off, and I was really hoping to see some nice white crystals, but they were still really dark. I feel like they might have even looked worse, which was a bit discouraging. Despite the color, it was still probably better than before, but I wanted to fix it up a bit more. However, I figured that doing another recrystallization with water was just a waste of time. So, what I did instead was put it all in a beaker and I started adding methanol. The anthranilic acid was much more soluble in methanol, and the goal here was to add just enough to dissolve everything. When it had all disappeared, there was still a small amount of junk floating around, so I quickly filtered it through some cotton. After that, I added cold water, which reduced the solubility of the anthranilic acid and caused it to separate. I then added a whole bunch of extra water just to make sure that I knocked it all out. This time, it looked way better than before, and when I filtered it, it actually kind of looked okay. To completely dry it, I put it into a vacuum chamber and I kept it under vacuum overnight. I opened it up the next morning, and what I had now was a light brown powder. Ideally, it would have been white, but as far as I know, not even chemical companies sell a perfectly white version. It's always light brown, or at least slightly yellow. What I also find interesting is that even though this is only one step away from the final grape flavor, it doesn't smell anything like grape. But anyway, overall, this reaction was a mess. I only ended up getting 10.2 grams, which wasn't amazing. If everything had gone well, it probably would have been closer to 25 or 30 grams, so this was a bit sad. But either way, in theory, this was still more than enough for the last step. I was slightly concerned, though, for what is probably now the millionth time, because this last step was also kind of bad and inefficient. But there wasn't much that I could do about that, and I kind of just had to hope for the best. So now, to make the final grape flavor, I put everything back into a flask and I added 75 mils of methanol. I stirred it until it all dissolved, and then I added some concentrated sulfuric acid. As it was added, it was reacting with the anthranilic acid to make a sulfate salt, which wasn't very soluble in methanol. It initially didn't look like too much was happening, but then a bunch of solid stuff suddenly separated out. There was so much of it that it caused it to freeze, and to loosen it up, I had to stir it manually. That didn't seem to be working too well, though, so I took it off the stand and I shook it around a bit. After that, I added some more sulfuric acid and I let it stir for 30 minutes. I also turned on the hot plate to try to get some of the sulfate salt to dissolve and to prevent it from freezing again. When I came back to it, I added the last bit of sulfuric acid, which caused the methanol to heat up even more, and everything dissolved. I then added a heating mantle and a condenser column, and I cranked up the heat. After that, I waited for it to come to a boil, and then I kept boiling it for 2 hours. The reaction that I was doing here was called a Fischer esterification, and I was reacting the anthranilic acid with the methanol. The reaction was catalyzed by the sulfuric acid, and the result was the methylantranilate grape flavor. However, it wasn't a free base, and it was still in its sulfate salt form. When it was eventually done, I took away the heating mantle and I let it cool down a bit. I then took off the condenser column and I was hit with the smell of grape candy. So clearly, it had worked, but I still had no idea how much I actually made. But either way, what I had to do next was try to isolate it, and I poured it all into some water. What I had now was still very acidic from all the sulfuric acid, and I had to neutralize it. To do this, I started adding a solution of saturated sodium carbonate. It immediately started reacting and releasing CO2 gas, and the pH slowly increased. Besides just neutralizing the sulfuric acid, though, it was also reacting with that sulfate salt of the methylantranilate and turning it into its pure freebase form. When I was done adding all the sodium carbonate, I dumped in a bunch of extra water. After this, the pH was close to neutral, and it was kind of hard to see, but it looked like there was a thin layer of oil at the top. Now, to separate the grape flavor from this mess, I poured it all into a separatory funnel. I then added something called dichloromethane, or DCM for short. This is a solvent that can dissolve the methylantranilate, but it isn't able to mix with water. After that, I dropped in a stopper and I shook it really vigorously, and then I waited for the layers to separate again. The lower layer was the DCM, and I drained it all into a beaker. I then did it 4 more times, which should have, in theory, pulled out close to 100% of the methylantranilate. After this, I cleaned out the funnel and I poured all of the DCM back into it. I then added some water to pull out any water soluble junk that the DCM might have picked up. I shook it around and I again drained out the DCM. I then cleaned the funnel and I did one last wash with a saturated salt solution. This was done to dry the DCM and to get rid of any water that might have dissolved into it. When I was done, I drained out the DCM, and the next thing to do was one last drying step. To do this, I just dumped in some anhydrous sodium sulfate and I stirred it for 15 minutes. After this, I got rid of the sodium sulfate by filtering it through some cotton, and I collected everything in a round bottom flask. What I had to do now was get rid of the DCM, so I put together another distillation setup. I turned on the heat and I brought it to a boil, which didn't take very long because the boiling point of DCM is only around 40°C. It also distills off really easily, and it didn't take very long for pretty much all of it to be gone. I was eventually left with a dark red colored oil, and I transferred it all to a much smaller flask. What I had now was really crude and dirty methylene, and I had to clean it up a bit more. To do this, I had to do another distillation, but it couldn't just be a regular one, and it had to be under vacuum. Doing it under a vacuum was very important because it would let me do it at a much lower temperature and without any air present. This would prevent the grape flavor from just decomposing or reacting with oxygen in the air. After a while, I started seeing vapor forming and condensing, and stuff started coming over. I'm not sure what this stuff was, but it was mostly side product and other junk. It was only when it got to around 131°C that the methylene started coming over. I then turned this adapter to a new vial, and I kept collecting it here until the temperature started rising again. I had no idea how much I was actually going to get, and I was a bit worried that it would only be a few drops. That didn't turn out to be the case, though, and I was really happy when I saw that I was collecting a decent amount. The moment that I saw it increase above 131, I turned it to another vial, and I collected it for a few minutes. I then turned off the heating, and I let everything cool down to room temperature. While I was waiting for that to happen, though, I wanted to try shooting it with UV light. I had read online that it was supposed to fluoresce, and I really wanted to try it out. So I turned off all the lights, and I turned on my UV lamp. The color that it made was honestly one of the nicest things that I've seen working on this channel. It's a bit unfortunate though, because I don't feel like the camera really did it justice. When it eventually got to room temperature, I released the vacuum, and I took the whole thing apart. I then pulled out the three separate fractions, and I put them into different vials. Just for fun, I smelled the first and last vials, and they weren't great. I'm really not sure how to describe them, but they kind of had a weird plasticky smell. The main stuff, though, smelled completely different, and it had a strong grape smell, but it also had an odd mustiness to it. I again don't really know how to describe it, but it was honestly a bit off putting. This surprised me because from everything that I had read, I thought it was going to be exactly like grape candy. At first, I thought that maybe it was just from an impurity. So, to compare it, I ordered a small amount of pure methylene from a chemical company. It ended up smelling exactly the same though, which honestly kind of surprised me. After that, I did something called thin layer chromatography to compare what I made with the stuff that I knew was pure. It confirmed that I did have methylene and it showed that it was pretty clean, so I guess that's just how it smells. But either way, after weeks of work, I was finally done, and I had more than enough to start putting together my grape soda. Before that, though, I just quickly wanted to taste it. Okay, so I'm hoping that it tastes a little bit better than it smells. God, it's awful. It's so much worse. And it also kind of burns. Oh. I'm going to be honest and say that I knew it wasn't going to be very good. But anyway, now to make the grape soda, I had to find a recipe, and it was surprisingly hard. I couldn't find anything that gave quantities, and it was always just generic ingredients. I also started realizing that I might have misread some of the info about methylene. A lot of sources said that methylene was used for the flavor of grape Kool-Aid and other grape products, and I thought this meant as the only flavor. However, I think it meant more that it was just one of the flavoring agents. I never thought my grape soda was going to be great, and this was making me doubt it even more. After not finding any recipes, I decided that the best thing to do was to just try and copy grape Kool-Aid. The ingredients were very simple, and even if other flavors were used, the methylphenolate was apparently the major one. From the ingredients list, I was able to get the amount of sugar that was in it, and I assumed that I would just have to do trial and error for the citric and ascorbic acid. However, I didn't have to do any of that at all because figuring this out is apparently a common high school lab. From their results, I was able to do some quick math, and I came up with my own bootleg recipe. I based the amount of acids on the Kool Aid, but I jacked up the amount of sugar to match other grape sodas like Fanta. Before doing this, I had no idea, but grape sodas apparently have an insane amount of sugar in them. So now, to put it all together, I started by adding a crazy 55 grams of sugar. After that, I shot in about 1.1 grams of citric acid and zero point 0.1 of ascorbic acid. I then poured in just enough water to get it above the fill line. It wouldn't be grape soda if it weren't purple, so I added some red and blue dye, and I stirred it until everything dissolved. After this, I was done making the base of the soda, which at this point was just some slightly acidic purple sugar water. What I had to do now was actually flavor it by adding the methylphenolate, and I shot in 2 doses of 12.5 milligrams. Normally, methylphenolate would be almost insoluble in water, but I think the acidity of the citric acid might help it dissolve. So, what I had now was hopefully some pure chemical grape juice, and the last step was to carbonate it. I did this using one of those household carbonator things, and I blasted it with a bunch of CO2. When I eventually felt that it was good, I pulled it off very carefully to prevent it from overflowing. After all this, I was now apparently done, and I could finally taste my soda and see how terrible it probably was. Okay, so the first thing I'm going to do is smell it. And it's it actually does kind of smell like grape, but it also still has that weird mustiness or kind of off-putting scent that the pure stuff had. I was hoping that it would just magically go away, but it's clearly still there. But hopefully, unlike the pure stuff, it's not going to taste horrible. It, okay, it does taste like grape soda, but it's maybe just a really bad version. It definitely has, like, it's hard to describe. It definitely has a grape profile to it, but it's really limited in flavor. And it's kind of like there's just that part that makes you know it's grape and nothing else, which I guess makes sense because I only added one ingredient. But honestly, I'll try it again. I think it's still better than diet soda. And I think if I were really desperate, I could drink it. I don't know if I'd enjoy it, but it's more than drinkable. It's really just the smell that's kind of weird. Okay, so my plastic glove soda wasn't amazing, but it did taste like grape, and that was all that really mattered. To me, just the fact that I started with vinyl gloves and ended up with something that tasted fruity was more than a success. Also, as an added bonus, I was really happy to find that chemical that I was missing to make synthetic hot sauce. I have no idea when I'll actually do that though, because these long synthesis projects take forever to film and put together. It doesn't seem like it from the final video, but it's really time consuming, and I think this one took over 40 days. But anyway, with that being said, I want to give a big thanks to all my patrons for making long projects like this possible, and to Audible for sponsoring this video. Audible is one of the biggest providers and producers of spoken word content, and they have a huge library of audiobooks and podcasts. They offer something in almost every genre, from mysteries and thrillers to romance or self development. For a long time, I was always someone who preferred to read a physical book, but I've come to really like audiobooks. They're especially useful because I don't have to actually dedicate time to reading a book, and I can just listen to them while I drive or edit videos. The last time that I talked about Audible, I was listening to Shoe Dog, which was written by the founder of Nike. Now, though, I've moved on to Apollo, which tells the story of the first moon landing. So far, I'm only halfway through it, but I've been really enjoying it. But with all that being said, if you're interested in getting into audiobooks or podcasts, Audible's definitely the best place to check out. Right now, they're offering a free trial, which gives you a free audiobook of your choice and access to their new Plus catalog. This gives unlimited access to thousands of select audiobooks, podcasts, and Audible originals. You can get started by going to audible.com/NileRed or by texting NileRed to 500 500. Done. That's it, right? As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.